Hey guys, we are going to use similar right triangles to help us understand that the change in y over the change in x is a constant rate of change in linear representations in our graphs. Okay, so Joe and Kelly are each going to find the slope of the graph shown by comparing the ratio of rise over the run. Use the graph to answer the questions below about their work. Okay, so in order to find the slope of the graph shown, Joe chose the points 0, 0, and so he chose the point 0, 0, okay, and he chose the point 2, 4, okay, to make a right triangle. So we're going to draw this right triangle on our graph. Okay, so here's going to be our rise. Okay, let's do that again. Okay, so our rise. And then let's get a different color for our run. Okay, so for our run, right there. Okay, and so let's go ahead and call this then the change in y. The change in y, which is our rise, isn't it? Okay, and then this horizontal line is going to be our change in x. Okay, so you can see then, since this is proportional, that our rise is from 0 to 4. Okay, so our rise is going to be 4, and then our run is going to be from 1 to 2. So it's just right here. So our change in y is going to be 2. Okay, so when we put the change in y, let's see, let's use the right color. Okay, so the change in y over the change in x, the change in x, we've got 4 divided by 2, and 4 divided by 2 gives us 2. So that was the change in y over change in x, or we might call it our slope. Okay, and so now we're going to look at what happens with Kelly. Okay, so Kelly, oops, sorry. Okay, so Kelly then, come on, in order to find the slope of the graph shown, Kelly chose the points 2, 4. Okay, so let's go ahead and get her points then. 2, 4. So 2, 4, there's her point, and 5, 10. So here's 5 and 10. Okay, so let's go ahead and find her right triangle. And so here's our rise, right here, making our right triangle, and here is our run. So we'll go ahead and say that this is going to be our change in y, our rise. Okay, and then here's our change in x, change in x. Okay, so our change in y for Kelly is change. Okay. Change in y over our change in x. Okay, so our change in x. So we are here at 4 and at 9. I'm sorry, this is off just a little bit. That's the way it goes. Okay, so our horizontal change is going to be 10 take away 4, which is going to be 6. Okay. And then our vertical change is going to be, let's see, 5 take away 2, which is going to be 3, right? Okay, so the vertical change, the change in x, is going to be 3. Okay, so the change in y, 6. The change in x is going to be 3. 6 divided by 3 gives us 2. 2. Okay, so our slope equals 2. You can see that the slope then for each of these points are going to be the same thing. Goodness. Okay, so the slope for each of these points are going to be exactly the same. Slope here is 2, and the slope there is 2. So our constant rate of change, the change in y over the change in x, for any interval on our linear slope should be equivalent. Okay, so I'm going to let you guys fill out the rest. It says, based on what you know, which of the following triangles would also lie in the line? Okay, so we're going to do the same thing. We're just going to look at, here's our change in y. Here is going to be our change in x. So change in y over the change in x. That's the same thing as rise over run, isn't it? 26 over 14. And that does not equal 2. Okay, so we'll do the next one now. And I think you could probably already see what the answer is. So we'll look at the next one. Change in y over the change in x. Change in y is going to be 36. The change in x is going to be 18. 36 divided by 18 is 2. Okay? So this would be the correct answer. Okay, I'm going to let you finish the rest of your notes and look through. You can pretty much do the same thing here. Okay, and so let's look at 11. The slope of the line is 1 over 5. Label the two right triangles with dimensions that would allow the triangles to lie on the same line. Okay, so we know that the change in y over the change in x is going to be 1 to 5. Okay, so I think that I'm just going to find equivalent ratios. I'm going to go ahead and multiply this by, let's say, 6 over 6. We know that 6 over 6 is just 1. Okay, so we're just multiplying it times 1 whole, but we're coming up with equivalent ratios. Okay, so this is going to be 6, our rise, and this is going to be 30, our run. Okay, so the change in y is going to say that's 6. And the change in x, let's call this 30. Okay, I'm going to let you do the next one. Okay, so, okay, very good. Thank you.